Welcome back to the Spring 2020 main stage. Hopefully you had time to enjoy the conference. Ben, did you get a chance to see any of the talks? What'd you see?
I did. I managed to see Jürgen talking about some of the things that they're going to do in Spring in the future, and also some opportunities that might afford us to maybe take away some stuff that perhaps isn't used quite as often anymore. And I also saw some crazy guy called Brian Lyles literally try and do a whole presentation without any slides. No slides, no safety net, total craziness. What about you, Brian? Did you see any?
Yeah, with the conference and also trying to get work done today, let's see, I saw my own talk. I thought it was pretty good. But I also saw the talk after mine, Andrew Jones, where she talked about the Java's past Java 8. And I just find it very interesting that we're still having this discussion because the Javas past Java 8 are better. So please move on if you can. So,
well, I heard about that talk as well. It had a lot of impact on Twitter. There was lots of folks using the hashtag SpringOne and talking about that talk. It went down really, really well. So I think you're right. It was a really good one. So, Brian, what do we have next for this? What's the theme for this next round of keynotes?
So the theme for this next round of keynotes is modernizing apps for cloud with Spring. And we have some fabulous Spring speakers lined up, including Chris Sterling, Madurabave, and Sebastian Delus. But first, don't we have a special guest, Ben?
We do. That's right. For the next 40 minutes or so, we're going to be handing over to SpringOne legend, my personal hero, and the only person I know who has access to an actual DeLorean. So, of course, that is Domain Drewitz. She's Director of Product Marketing here at VMware. So, Domain, if you're there, take it away.
Thanks, Brian and Ben. One thing technology and humanity have in common is that they're never standing still. As technology advances, the choices we have in developing applications evolve. The promise of modernization is as much for existing applications as it is for new, so-called greenfield applications. It's funny the way history changes course sometimes. Whether it's a meteor out of the sky, a bacteria in the fleas on rats, or an invisible virus, sometimes something comes along and changes the economics of the way things get done. Containers are a little bit like that. We've known about service-oriented patterns for decades. We've always wanted to modernize applications to be lighter weight. But containers and Kubernetes came along and changed the economics of modernization and how we actually build and run microservices. Of course, the real challenge is finding the willingness to change what we're already doing. It's humbling and it's hard and it's uncomfortable. Whether you do that work or not, the world keeps turning. Your competitors keep shipping. Nothing stands still. So now that technology has evolved, the juggernaut of Kubernetes has made landfall, leaving a wake up and down the stack. What are the challenges facing developers in the enterprise? This is by no means an exhaustive list, but here are 4 things that stand out. First, faster startups to enable new workload styles like functions as well as responsive autoscaling of applications to handle load spikes. Second, distinction and support for long and short-running applications, which have unique implications for restarts, the so-called one-factor app, and monitoring. Third, being able to scale to 0 to allow for better resource utilization and energy savings, as well as financial savings as you pay only when used. Finally, lowering the memory footprint for running multiple microservices instances. This is one of those trade-offs we face when we break up a single monolith into many microservices. These are some of the challenges raised by modern architectures, but do they only help so-called modern architectures and applications? We're constantly redefining what modern means anyways. Are microservices the holy grail of modern architecture? When you look at these challenges, microservices that do one thing and one thing well certainly stand to benefit. What about existing applications packaged as native executables so that they can start instantly? That seems like modernization in action too. As we heard from Jürgen, Spring is always embracing this evolving technology landscape while looking ahead to new applications, but not losing sight of existing applications. Joining me today are 4 members of the Spring team to take us through the evolving set of capabilities for Spring developers to use in building new, modern apps and modernizing existing applications. First, we've got packaging your applications as containers, compiling new and existing applications as native executables, optimizing the cost of the cloud hosting of your microservices, using new programming models such as reactive versus imperative or functions versus web apps, pluggable activation and invocation models that allow the same set of functional workloads to be exposed as different application styles, such as a REST call or messaging or more. By doing so, you're effectively deferring the nature of the application to the assembly and packaging. But first, let's talk about 1543, because that's why you're all here, right? Okay, indulge me for just a moment, I promise. This is relevant to our first Spring Spotlight. In 1543, Henry VIII of England got married for a 6th time, the Ottomans captured key cities in Hungary, and a Polish mathematician published an argument that debunked the long-standing model that the Earth was the center of the universe. Copernicus's theory of heliocentricity literally changed the presumed center of the universe. These charts may look similar at a glance, but there's an important difference. Look closely at what's at the center. It's a lot like what we're seeing in the Spring Boot world today. And to tell us more about the changing center of the universe in Spring terms, I'm pleased to introduce Madurabave, software engineer for Spring Boot.
Thanks, Doreen. Hi, everyone. I'm excited to talk to you about the new center of the universe. And since this is a Spring conference, I'm going to be focusing on the center of the JVM universe. When it comes to the JVM universe, what I really mean by a new center is that there's a new unit of deployment. So let's take a look at what that means for you as a Spring Boot application developer. And for that, let's take a step back and look at how Spring Boot applications are typically run. Once you've written your source code, one of the easiest ways to run a Spring Boot application is using the Maven or Gradle plugin to create a fat jar. A fat jar is a self-contained jar which contains all of the application's code and its dependencies, and it can be run using java-jar, or it can be deployed to a cloud platform. Now, as we all know, the only constant is change. And one of the more recent changes in the software industry is the rising popularity of Kubernetes. What does that mean for Java applications? Well, the first thing you need when deploying an application to Kubernetes is a container image. That means that the unit of deployment to deploy an application to Kubernetes is not the fat jar, but a container image which packages up the application and all of its software dependencies. At this point, you're probably wondering, well, how do I get from a fat jar to a container image? And like most software developers, you go to Google. You type in how to create a container from a jar, and the first few results might not be exactly what you're looking for. So you scroll down a bit more and get to Dockerfiles. It's always been possible to package a Spring Boot application as a Docker image using Dockerfile. So you copy-paste that Docker file, run Docker build, and get a Docker image. If we look closely at that Docker image, it consists of 3 layers. The base layer has the OS, on top of which is the JDK layer, and then the last layer has the application's fat jar. But this is not optimal. There's a few reasons for this. The entire contents of the fat jar are in a single layer. This means that whenever the application's code changes, the entire layer, which includes your application's dependencies, needs to be rebuilt, which results in a waste of time and disk space. The second reason is that the application is run as a fat jar, and when running the application as a fat jar, there's a certain amount of overhead associated with it. So one way to optimize the Docker image for a Spring Boot application is to split the fat jar into multiple layers. As you see here, there's one layer for dependencies, which tend to change least frequently. There's another layer for the Spring Boot loader classes, a layer for the snapshot dependencies, and the topmost layer is for the application's code. So whenever the application code changes, it's just that topmost layer that gets rebuilt again. To help you create these optimized layered images, we've added image creation as a first-class concern in Spring Boot 2.3. The Dockerfile that you see here is an example Dockerfile from the Spring Boot 2.3 reference documentation. It might look a bit verbose at first, but it's more performant. It is a multi-stage Dockerfile where the first stage is used to set some things up that the second stage will then use. To help with image layering, we've added something called a jar mode, and the first one that we're offering is Layer Tools. When the jar is launched using the Layer Tools jar mode and the extract option, the jar can self-extract itself into layer folders. These layer folders can then be used in the second stage to create a layered image. The way that Layer Tools knows which layer folders to extract the jar into is using a layers index file. We've provided sensible defaults for the layers index file that should work for most Spring Boot applications. If your application has special requirements, you can customize the layers index file using both Maven and Gradle. The next thing I want to talk about is the buildpacks.io project, or Cloud Native Buildpack. Docker files are just one way of creating container images, but they require you to know a lot about how Docker files work, which application developers shouldn't necessarily need to learn about. The buildpacks.io project is an open source project developed jointly by VMware and Heroku, and it can take your source code and turn it into a container image without using Docker files. Not having to learn about Docker files and how they work is just one advantage of using buildpacks. There are several other advantages, an important one being automated security patches. I guess you're wondering if this is another tool that you need to learn about. And the answer is not really. We've got your back. With Spring Boot 2.3, there's direct integration with the Cloud Native Buildpacks via both the Maven and Gradle plugins. You can use the Maven or Gradle plugin to create a container image for your application using buildpacks and a single command. The buildpacks have been updated to honor the layers index file, which means that any customization that you've applied to the layers index will be available in the resulting image as well. Your Kubernetes journey doesn't end at image creation. There's a few things that you need to set in place to ensure that the application runs smoothly in production on Kubernetes. To determine if the pod is alive and ready to accept traffic, Kubernetes uses something called health checks or probes. In Spring Boot 2.3, we've added Kubernetes probes as a first-class concern and exposed them via Spring Boot actuators. You can use the actuator liveness and actuator readiness health groups to signal to Kubernetes if your application is alive or if it needs to be restarted, and if it's ready to accept traffic. Graceful shutdown is another important feature when deploying to a cloud platform such as Kubernetes. Looking into the future at Spring Boot 2.4, we're planning to add support for Kubernetes volume-mounted config maps and secrets, and make those available as property sources in the Spring environment. We've deployed our own production application, start.spring.io, to Kubernetes using the new Spring Boot 2.3 features. We hope that these features, along with the upcoming ones in Spring Boot 2.4, will enhance your experience when running a Spring Boot application on Kubernetes. If you want to learn more about how Spring Boot and Kubernetes work well together, I'd recommend watching the breakout session by Stefan and Brian. Thank you very much, and back to you, Doreen.
Thanks, Madura. So you saw how Spring Boot is making it easier to package up your Spring application into a container. That's useful. Containers, of course, are lovely because you don't need a full operating system in the image. making them lighter weight. So, what if we took that approach up to the JVM layer itself? To tell us a little bit more about where Spring is going with respect to so-called native executables, please welcome Spring Framework committer Sébastien Deleuze.
Hey, I'm Sébastien Deleuze. I work at VMware as a Spring Framework committer, and today I would like to talk about the path towards Spring Boot native applications. GraalVM is a project started several years ago by Oracle. It allows, among other things, to perform ahead-of-time compilation of a Java or Kotlin application in order to generate a native executable that can run on its own without the need for a Java virtual machine. Such native executable can then be used to create a lightweight container image. There are two main benefits in doing that: instant startup with peak performance available immediately and lower memory consumption. Project Laden, recently announced by Oracle, will introduce this kind of native ahead-of-time compilation to the Java platform and to the JDK. While those new capabilities are super exciting, I think we need to keep in mind that they offer different trade-offs compared to the JVM. While native executables really shine on startup time and runtime memory footprints, they offer lower throughput and higher latency because they use a more basic garbage collector and can't optimize that path during runtime as the JVM can. Compilation takes much longer and consumes more resources. The platform is also less mature, but it evolves and improves very quickly. So let's talk about the current status of Spring support for native applications. Spring and GraalVM teams have been collaborating very intensively to make it possible to run Spring Boot native applications. Here is a quote from Thomas Verslinger, the GraalVM founder and project lead, who said, "We are excited about the great partnership between the Spring and GraalVM engineering teams to support native ahead-of-time compilations for millions of Spring Boot applications. This is a game changer, enabling low memory footprints and instant startup for these workloads." As a result, most of the GraalVM bug fixes and improvements required to run Spring Boot native applications have already been done. It is currently possible to compile Spring Boot's application to native executable thanks to the incubating Spring GraalVM native project. We have just released the 0.8 milestone, and the compatibility is for now limited to a subset of Spring Boot starters. We observe between 3x and 5x reduction of the memory footprint compared to the JVM, which is very significant. It is available for you to try with your application and start to flesh out any issues early, so feel free to try it. Notice that we are also contributing GraalVM native related improvements to other open source projects we are involved, like in Tomcat. Upcoming Spring Boot 2.4 release based on Spring Framework 5.3 already integrates improvements originally incubated in Spring GraalVM native. We have also incubating support for Spring Boot native application in Paketo build packs, since they enable to build lightweight containers. On this slide, you can see that we are using a minimal Ubuntu-based image consisting of only 7 packages optimized for security and size. I'm now going to show you a quick demo of the famous pet clinic sample compiled to a Spring Boot native application and deployed as a container. Notice this is a regular Spring Boot application using annotation, controllers. We also have a domain object. And we are going to the Maven configuration in order to indicate that we want to create a native application. In order to do that, we are going to leverage Spring Boot support for creating container image that's available as of Spring Boot 2.3. Here we specify a dedicated builder that allows to create a native image. We also specify a few command line arguments that will be forwarded to the native image compiler. For the purpose of this demo, we are going to add a dependency on Spring GraalVM native, because here we are using the latest development version. Spring GraalVM native is this project where we incubate the support for native application. You can go here on the issues to raise an issue if you find something. You can also follow the roadmap. And we also publish a reference documentation if you want to learn more about that. But back here, we have specified our configuration. So now we are going to build the native image via the command maven Spring Boot build image. It will run our unit tests, and if everything is okay, it will start a container, run the native image compiler that will translate, with the help of Spring GraalVM native, the JVM bytecode of your Spring Boot application into a native executable. It can take a little bit of time, so we are going to fast forward here. Okay, we now have a lightweight container with our native application in it. We are going to our Docker Compose configuration. We already have a MySQL service, and we are going to add Pet Clinic 1. Okay, so we now are going to start the MySQL service. And we are going to start our Pet Clinic service, which is in fact a lightweight container with a native application. Notice that it starts very fast, almost instantly. And if we go in the browser, you can see our regular Pet Clinic application that works perfectly fine. You will learn more about how to deploy this kind of application as a scale to zero application with Grant demo. So let's now talk about the next steps. The Spring team is on a journey to optimize the cost of running any Spring Boot application by supporting native ahead-of-time compilation in order to achieve scale to zero capabilities and reduce memory consumption. Combined with Kubernetes-based platform like Knative, that means you can run your regular web application in a serverless fashion and only pay when your application is used. There has been a hidden gem in Spring Framework 6.5.0. Functional bean registration, which allows to register beans using lambdas. With this mechanism and some related changes we are working on, it is possible to achieve out-of-the-box Spring Boot native application support with a 5x memory footprint reduction without changing the Spring Boot programming model that you all love and use. Spring Boot 3, based on Spring Framework 6, is expected to provide first-class support for native applications, to give you more options when it comes to deploying your Spring Boot application as containers on Kubernetes. We intend to adapt Spring to GraalVM native as well as project native. The related changes will optimize the footprint of Spring Boot application on the JVM as well. I think what is unique about our effort is that we not only target new Spring Boot applications, but also the millions of existing ones. Thanks.
Thank you, Sebastian. Exciting stuff, right? There is definitely room for faster start times and lower memory consumption in existing applications. But in some cases, it's almost required for some newer architectural patterns. It all comes down to changing the economics to unlock these innovative new patterns. Functions and serverless are some great examples of where those fast startup times are really useful. Scale to zero becomes a practical option. Here to tell us more about how Spring is enabling Java developers to write functions so much more efficiently is Spring engineer Oleg Zurkowski. But first, he's going to talk about one of my favorite topics, besides medieval European history, ice cream.
Thank you, Darmaine. So we just heard about scale to zero capabilities and how they support new serverless apps from Sebastian. So let's look at one of those approaches you can take to implement these apps using Java functions and Spring Cloud Function Framework. But before I get all taken functional on you, let's talk about something important, something that will really help us better understand the value of functions. And that is, of course, ice cream. Why is ice cream so important? Well, I, for one, have never met a person who doesn't like some kind of ice cream. It is something that easily connects people, and it is something that happened to be very relevant to Spring overarching message, a message that hasn't really changed since the first release of Spring in June 2003. And that is, user concentrates on functional requirements, and Spring helps with non-functional and boilerplate concerns. Well, how so? What is the relevance? Here's the story of two strawberry ice creams. Well, actually, it's the same ice cream captured in two stages of serving, and it helps illustrate the core Spring message in a kind of a tasty way. The picture on the left shows a scoop of ice cream simply thrown on a plate, and the picture on the right shows the same scoop nicely decorated, plated, and served to trigger additional senses, or to add flavors, or to simply charge you more. Whatever the reason may be, the contents of the ice cream never change. What has changed is how it was decorated, plated, and served. So now we have a simple implementation of Java function that does something. In this case, it simply uppercases the string, but it knows nothing about how it is going to be decorated, plated, and served to ensure proper invocation within the given context. Functions are like the scoop of ice cream. They're raw material. They represent functional aspects of your requirements, such as add user, access account balance, uppercase the string, but have no knowledge or awareness of anything non-functional. But now you can decorate and serve its functionality, let's say, over HTTP, effectively turning these functions into a REST endpoint. Or maybe you want to turn it into an RSocket consumer or producer, which supports many RSocket operations. There's actually going to be a whole breakout session on functions in RSocket. Or maybe you want to deploy to one of the popular serverless platforms, such as AWS, Azure, Google. Or maybe you're considering a full-blown messaging app where the same function acts as a message handler with its input and output corresponding to different broker destinations, which in itself opens up a very interesting opportunity where you can now start thinking about creating these distributed pipelines and data flows. Whatever the nature of the application may be, the function is still uppercase, the ice cream is still strawberry, and the only thing we're changing is the non-functional world around it. And we can accomplish it with the magic of Spring Cloud Function and Spring Boot. All right, so we're at the point of a mandatory bullet point slide. So what is Spring Cloud Function? It is one of the frameworks from Spring Cloud portfolio, which promotes implementation of functional requirements via Java functions. It provides a uniform programming model that, amongst many things, supports transparent type conversion, function composition, POJA functions, reactive support, deployment support, and many more. It also provides adapters in the form of Spring Boot auto configurations for a variety of serverless platforms, such as Microsoft Azure, Amazon AWS, Google Cloud, and so on. So let's see it in action.
So here we have a simple function, which is uppercase. And the first thing we want to do is we want to expose this function as a REST endpoint. So within this project, we're going to go to its pump file. And as you can see, I've already exposed these two dependencies, which is Spring Boot Starter Web and Spring Cloud Function Web. So all we need to do now is start the application. We're going to go to the browser. We're going to type uppercase, which is the name of the function, and hello world. And now we got yourself a hello world uppercase. So just like this, a simple function became a REST endpoint. But please note that from the application definition, this is just a plain Spring Boot application. All this decoration came from by declaring certain auto configurations within your pump file. Moving on, now we want to do is we want to turn this function into a message handler. So in this case, we're going to be using RabbitMQ and Spring Cloud Stream RabbitBinder, which provides capability to treat this function as a message handler. Again, just expose a dependency, start the application, and then we're going to go back to the browser. We're going to go to the Rabbit console, and we can see in exchanges we have uppercase in binding. So we're going to click on it and type hello world. And we can see the console, the function was executed and the message was uppercased, and everything worked as expected. Moving on. Now we want to turn this function into an RSocket handler. So all we need to do is, again, expose the dependencies, require dependencies. I'm going to write a little RSocket client code here just to make sure we can invoke it. And we can simply run the app. And as you can see, the function was invoked and everything was uppercased now via RSocket. And last but not least, we can now also deploy this function, for example, into one of the serverless platforms. I'm going to use AWS for a demonstration, AWS Lambda. So again, this is, I'm actually showing one of the samples that we have in Spring Cloud Function. So function sample AWS. Here we have the configuration. As you can see, it's identical function, which is uppercase, and just a simple Spring Boot app. And for the sake of saving time, I've already deployed it. So I'm going to go to AWS dashboard. Here is the uppercase function. I'm going to click on it. And I'm going to invoke it with the sample output input. And here we go. We got yourself an execution.
As you can see, the concept of handling non-functional requirements is delegated to opinionated Spring Boot auto configurations, typically requiring very limited to no involvement from the end user. These auto configurations not only satisfy the dependencies required by the application itself, but they also decorate the function with execution context-specific behavior. So, the result, functions are simple, expressive, extensible, and portable. Most, if not all, requirements could be expressed with functions. In fact, I'm going to challenge you. Think of requirement, past, present, or future that you cannot express with functions. See if you can think of one. Testing. Testing a function's application becomes very simple since you only need to test function itself. Delegate the rest of the framework that you're using. The list of these benefits goes on, but no matter how long it is, the results are still the same. Any functionality expressed as Java functions can now be exposed as a variety of applications by simply providing the relevant auto configurations. And that's it. So, enjoy your functions, enjoy your ice cream, and back to you, domain.
Thank you, Oleg. Who's ready to write some functions? Did anyone else feel like there was a seriously Oprah moment when he let all those different apps activate the same function? Like, you've got a function, you've got a function. Just think, you can have your own Oprah moment, writing Spring Cloud functions. Look under your chair because you've got a function under there that's just waiting to be activated. Okay, enough jokey joke time. In all seriousness, no function or application for that matter is an island. The apps, functional or otherwise, connected to messaging brokers in a way that was just demonstrated by Oleg, can effectively communicate with another app where the data produced by one app may become an input to another app, and so on, effectively creating a data-driven pipeline. As we think about all the novel ways of using data that Ajay referred to this morning, AI and machine learning and IoT use cases, and how to actually build those data-driven pieces of functionality into our applications, we're going to need to support those event-driven architectures. The good news is Spring totally lets you do this. The challenge is, how do we orchestrate lots of these messaging-driven functions and other services, some of which need to share streams of data? Here to tell us more about that is Spring software engineer Elia Gopinathan.
Thanks, Domain, and hi, everyone. Streaming and batch applications play a crucial role in modernizing data-driven applications. In the previous keynote, my friend Oleg mentioned how one can bind a simple function's input and output to a messaging system using Spring Cloud Stream Framework. In a way, that simple function would look like this: simple and straightforward to deploy and manage, a single car on an open road with no turns. But in reality, it's not just a single application or a single function you would end up deploying and managing. Typically, this involves multiple applications forming a streaming pipeline and all the operational concerns around them. In other words, your production deployment looks more like this complex interchange during rush hour. This is where Spring Cloud Dataflow comes into play. Spring Cloud Dataflow gives us a tool to first construct a streaming pipeline of individual applications or compose batch applications. Second, it lets you automate the deployment configuration. For instance, if you're deploying your streaming application into Kubernetes, Spring Cloud Dataflow takes care of generating Kubernetes manifest files based on your stream configuration. Spring Cloud Dataflow also gives us continuous delivery option for individual applications of a stream or batch application. Finally, Spring Cloud Dataflow lets you securely manage streaming pipelines and batch applications on top of metrics and monitoring support from Micrometer library. With this, let's see a demo. I have set up Spring Cloud Dataflow on Kubernetes. I got RabbitMQ installed as my messaging system. I have also configured Wavefront to monitor my streaming and batch applications. I have also pre-registered the container images of the out-of-the-box applications, which were pre-built using the RabbitMQ binders. And Spring Cloud Dataflow provides a web user interface. And for this demo, we are going to use just that. And for this demo, I'm going to create streaming pipelines that ingest HTTP events. And this is how my HTTP event looks like. A HTTP post request with the user ID set as one of the headers, and then the payload with the purchase transaction information. With this, let's create streaming pipelines. We are at the streams creation page. Here, you can drag and drop the individual applications connect them to form a streaming pipeline. The pipeline here represents the underlying messaging platform, meaning both HTTP and JDBC applications are distributed applications connected via a RabbitMQ exchange, with HTTP source acts as a producer to the exchange, JDBC sync acts as a consumer to the same exchange. For this demo, I have 3 streaming pipelines. With my first stream, ingest all the incoming purchase records into a database. The second stream gets only the credit card purchases into a MongoDB data store. My third stream extracts the zone information from the credit card purchase records, transforms that zone information, and logs it. As you can see here, we can tap into an application's output and create multiple streaming pipelines. This is because of the consumer group support that Spring Cloud Stream has. Every time a new stream is created from an outbound endpoint, a new consumer group is created, making the stream a unique consumer to its producer's output. At the time of stream creation, you can add the individual application properties in the context of the stream. In this case, we've got an application property for the HTTP source to map the request header. For JDBC sync, we got the column mapping and then the table name. For MongoDB, we set the collection name. And for the filter, we got a spell expression to allow only the credit transaction. And similarly, for the transform, we got a spell expression to just extract the zone information. As you can notice here, we have not specified any of the connection parameters of the database, which we can specify at the time of stream deployment. With this, our streams are ready to be created. I've got MySQL and MongoDB databases created on Kubernetes with their corresponding table and collection. With this, my streams are ready to be deployed into Kubernetes. Let's get to the stream deployment page. Here, one can choose a specific Kubernetes account to target the stream deployment. Also, you can provide deployment properties that are specific to Kubernetes objects such as pod, container, deployment, and service. In this case, for the HTTP source, I want to set a load balancer type for its service. Similarly, for the JDBC sync, I want to associate the MySQL database's config map to its pod. With this set of properties, my stream is ready to be deployed. In the same way, we can go ahead and deploy the rest of the streams. Here, I want to add the MongoDB config map to the sync and deploy. You can see the corresponding Kubernetes objects getting created as this stream gets deployed. You can also see the previous stream's objects here, and you would also see the load balancer for the HTTP source. With this, let's deploy our third stream with the default settings. We've got all the streams deployed successfully. Let's post some events to see them working. Now, after posting these events, I expect all the records to be available in my MySQL database and only the credit purchase records available in my MongoDB, and the zone information of the credit purchase record is expected to be in the logger streams log output. Let's see that to confirm the result. Yes, now we can confirm the stream's working. Let's say I want to update the individual applications of the stream. This could be change in the deployment properties. Say I want to add a new resource limit, or I wanted to add a pod annotation. Or this could be a change in the application itself. Say you have a business logic change or a bug fix. So you would register a new container image version and select that here. Or this could be a change in the application property. For this case, I'm going to change the filter logic to allow both credit as well as debit purchase records. When I update the stream, only the applications that have changed are going to be updated. Now you can see that the stream is updated and versioned. We can roll back to a specific version of the stream as well. Now we can post some events to confirm the stream update. And let's make sure that the MongoDB has both credit as well as debit transactions, and MySQL has got all the transactions. Since we have configured Wavefront to monitor our streaming applications, we can go to the Spring Cloud Dataflow dashboard in Wavefront and monitor our streaming applications from there. Similarly, you can compose, schedule, and launch batch applications using Spring Cloud Dataflow. We have a dedicated breakout session on Spring Cloud Dataflow. My friend Glenn and I are going to present various features on Spring Cloud Dataflow there. So stay tuned, and thank you.
Thanks, Elia. Folks, thank you for taking this journey with me through these evolutions in Spring that are opening up new patterns and use cases, as well as ways to improve and modernize existing applications. Be sure to check out the breakout sessions to go deeper on each of these topics. Back to you, Ben and Brian.
Thanks, Dormain, Madur, Sebastian, Oleg, and Elia. Wow, lots of cool tech in Springland covering a whole bunch of popular projects and APIs. If you like that, be sure to catch Oleg's talk, Connect Your Functions with RSocket, right after tomorrow's keynotes. Who's next, Ben?
Well, next up we have Phil Clay. He's a principal software engineer on the BattleNet team at Blizzard Entertainment.
I've been looking forward to this one all day. I like to play.
I bet you do.
Are you a fan of Warcraft, Ben?
Do you know what? I have to confess I haven't played it, but I do like science fiction, so probably something like StarCraft might be more my sort of thing. I've seen it on YouTube, and it looks really awesome. So, yeah, if I was to check it out, it'd probably be that. But back in the day, my brother had loads of Warhammer stuff, Warhammer 40,000, you know, the little models and all that sort of stuff. Used to paint them on the kitchen table. So fond memories. But does that count?
Well, not really. But Warcraft was huge. I can think back about 15, 16, 17 years ago where that's all I did. I went to work, I played Warcraft. And then I went to work, and I played Warcraft. But, you know, we've grown up, and I don't play Warcraft anymore, but I still appreciate it.
Yeah, and I noticed there was no mention of personal hygiene there. So good for you, living the dream. Well, on that note, let's not wait any longer. Let's go over to see what Phil has to say and let him fill us in on all the things that Blizzard are doing with Spring.
Blizzard makes awesome games, and we want to make sure our players around the world have a great experience, not only within the games, but outside of the games as well. For example, whenever new players sign up, we need to capture data and perform validations that vary according to local laws and regulations, age, authentication provider, and even how they're creating their account, whether it's on the web, within a game, or on a mobile device. That experience has to be fast and low friction. And one of the ways we're making the player experience fast is to deploy our services closer to our players in data centers and clouds around the globe. However, inevitably, some of our services need to talk to remote services in other locations, and we get into a challenge that in our world is governed by the laws of physics, and that is latency. So over the years, we've introduced several asynchronous styles to help make our Java services more responsive in the presence of latency and other long-running tasks. We've used callbacks, promises, futures, completable futures, but introducing these styles came with their own challenges. They're not a great fit for complex composition and data manipulation. They don't really handle back pressure, so slowdowns in the middle of a flow are not handled very gracefully. It's hard to determine context within an asynchronous flow whenever you're debugging problems. And it's also difficult to write and maintain common libraries for all the different styles. So we found that replacing those async styles with Reactor offers a much more rich, elegant API. The operators offered by Mono and Flux are perfect whenever you're composing many data streams and data manipulations together. For example, during the account creation flow that I mentioned, we pre-assemble a bunch of reactive publishers that describe things like transformations, decisions, validations, default values, and remote operations. Then we later combine all those dynamically to assemble a full stream that represents the full creation flow that applies for a specific use case. Effectively, Reactor provides the building blocks to create and cache streams at assembly time, and then defer I/O until absolutely required at subscription time. In addition to async programming efficiency, we're seeing runtime efficiencies as well. For example, back pressure provided by reactive streams helps our services tolerate latency better, particularly as we move to more and more locations around the world. So back when we decided to start utilizing reactive streams, we recognized we needed to add reactive support to our common libraries that tie our apps into the rest of Blizzard's operational systems. So we've added reactive support to our metrics and our tracing instrumentation to ensure that reactive apps are just as observable as our non-reactive apps. We also made reactive versions of our communication abstractions for RPC, AMQP, and WebSocket traffic. For example, we replaced future and promise-based Netty code with WebFlux and Reactor Netty. We replaced async listener-based RabbitMQ code with Reactor RabbitMQ, and we replaced callback-based RPC code with other reactive clients. We also took the opportunity to migrate from the old deprecated Spring Security OAuth library to the newest Spring Security releases, which provides reactive OAuth support. We even started to use the reactive types as a common API for our cross-cutting libraries so that we don't need variants for each async style. So all these changes let applications be reactive through the whole stack, which really unlocks the power of Reactor. However, we do have some apps where we've only introduced reactive clients without handling inbound traffic reactively. So this has helped developers become familiar with reactive programming before taking a big architectural leap for those apps. And speaking of developers, one of the biggest challenges of getting to production with Reactor is for developers to be able to effectively troubleshoot reactive applications. Generally, we start troubleshooting with metrics and tracing and logging information to kind of narrow down where to investigate. And since we've added reactive support to our observability libraries, we can take advantage of all of our existing monitoring and alerting capabilities. So at this level, reactive apps are no different than our non-reactive apps. Once you get inside the app, however, things change. So reading stack traces is different, debugging is different, and profiling is different. But luckily, there's some tools to help with all this. We use the Reactor debug agent to show assembly traces for exceptions and whenever we're debugging in IntelliJ. So this provides a better context as to where a problem has occurred within a stream. And we use block count and IntelliJ inspections to identify improperly blocking code. And we use async profilers to identify bottlenecks that traditional profilers can't find. So with all this, troubleshooting reactive apps is much easier than other async styles, but still harder than the synchronous style. It's not impossible, it just takes a bit of learning and the right tools. And on that note, we've learned a few other things as we've used Reactor more and more. The first is to only introduce reactive streams where it makes sense. It's not for everything. Target your high throughput workloads, your apps that are already asynchronous, or your apps where you want better back pressure support. Then make sure all the operational features of your applications are all covered. By that, I mean metrics, tracing, communication, security, health checks. The Spring ecosystem actually covers a lot of these concerns with projects in Spring Boot, Spring Security, and Spring Cloud Sleuth. But if you have any additional abstractions or you're using homegrown variants, then you'll need to put some time into supporting the reactive style. And finally, as with any technology, there's definitely an upfront learning curve with reactive programming. So plan for that. Read guides, watch these SpringOne presentations, and have knowledge sharing sessions. It takes time, but it's not insurmountable, and it quickly becomes second nature.
Thank you, Phil. The fact that the software we make powers our favorite games never gets old to me. And Blizzard is clearly all in on reactive. That's cutting edge stuff for most folks. Pretty interesting. Now, you know, we've had over 40,000 people registered today. We've had a ton of useful feedback, hundreds of photos, and thousands of likes. Ben, what's going on Twitter?
Yeah, great point, actually. So let's take a quick look. Here's some highlights that I picked out earlier. So first of all, Austin Gua, I hope I've said that correctly. Apologies if I've not. He said he loves the streaming platform, is really enjoying the website, being able to catch all those important conference talks. Next, we have Jose Diaz. Jose says, conference is incredible. Congratulations, everyone. And I got to echo that. It's really, really good. I was watching earlier myself as well, and I really enjoyed it. And then we have Marino YJ, I'm not sure, but he's been spending a lot of time on Kubernetes recently, but he's really glad that his Java skills haven't gone to waste. And well, that's Spring for you. Can you imagine a world without Spring and just Java? I can't, to be perfectly honest. So yeah. So thanks everybody for getting in touch. keep those tweets coming. Hashtag SpringOne. Maybe if we get time tomorrow, we'll read out some more.
Right. Well, thank you, people of Twitter. We really appreciate all the support. So, Ben, can you introduce our final speaker for today?
Sure thing, absolutely. So next up, we have Colonel Jennifer Krolikowski. She's a senior materiel leader for the USAF, specifically Space C2, which is more widely known as Space Force. And she's talking about how even the biggest government organizations can get to production quickly if they have the right stuff. Pun most definitely intended.
Hello, everyone. I'm Colonel Jennifer Krolikowski, and I serve in the newly established Space Force, and I'm currently the Senior Materiel Leader for Space Command and Control at the Space and Missile Systems Center here in sunny California. And although we should not be confused with the popular Netflix series Space Force, we are proud to be a part of the real-life Space Force that's bringing amazing capabilities to our warfighters in order to defend our interests against the growing and emerging threats of space. As a critical unit within the Space Force, it is our mission to provide space domain awareness and battle management command and control at the operational level of war. This is made possible because we aggregate all of the data that we need and then convert that data into knowledge so that our warfighters can make decisions about the domain and what effects that they want to be able to create. Some of that type of knowledge could be upcoming space launches, potential satellite conjunctions, atmospheric reentries of space objects, and sensor status. Kobayashi Maru, created under the Cross Mission Ground and Communication Enterprise, is our very own space software factory located here in El Segundo. In military software factories, we work hand in hand with developers and the operations community to create software applications that help us provide the awareness we need in space to ensure that we sustain our advantage in the space domain. So Kobayashi Maru is a Star Trek reference. It was an exercise that all Starfleet Academy cadets had to go through to see how they would handle a no-win situation. There was one individual, James T. Kirk, who changed the conditions of the scenario in order to actually win the exercise. That's exactly what we have done in software within the government. We've changed the conditions of the scenario. We are pushing the boundaries and challenging ourselves to deliver capabilities to the warfighters smarter, faster, and better for the protection of our country. Gone are the days of that slow waterfall procurement. In just 2 years, we have fully embraced Agile and DevSecOps practices in order to deliver capability at the speed of relevance. But more on that a little bit later. One of the first things that we did was break apart the stack so we could capture the best in breed for each layer. It's a bit analogous to your smartphone. So think about your phone itself as the infrastructure. The platform is analogous to your iOS or to the Android. Your application layer is, well, you understand applications. Could be your weather app or your map app or something like that. The data layer that we have is actually the information that feeds into those applications, like your weather or your map. Each piece can include multiple products, letting us work with a variety of partners, such as VMware, Tanzu, and Pivotal Labs. In some cases, software teams are automating and modernizing old code. In others, they're developing new applications from scratch. The types of applications we build span from space object tracking to indications and warning about irregularities in the space domain, and tools that help us facilitate tactical responses. What makes us unique is our focus to hire and maintain versatile, talented employees who can think like disruptors. That focus is why ours is the team that can quickly adapt to a changing environment, the team that has the advantage in the digital frontier. We've had to bring in people from all backgrounds, whether it be military, government civilians, or contractors, with skill sets that span between coders, program managers, engineers, cyberspace and cybersecurity operators, intelligence analysts, and system administrators. We're really trying to include and attract commercial companies that typically wouldn't work for the Department of Defense, but we recognize that they have innovative software solutions that can help us solve some of the biggest challenges that we face. We set up small teams of software developers who use agile software practices to deliver new applications to our space operators on a weekly basis. This is ensuring innovation, timeliness, and speed. Among our biggest successes has been developing an application from the time that the team stood up to it being operationally accepted by our users in a mere 6 months. Previously, within the legacy system, this capability would have taken 3 years and cost 10 times as much. We now have several applications on that ops floor today. Additionally, we took an enterprise approach and went cloud native as much as absolutely possible. So anyone with the right permissions can access that particular capability. In the past, code was written as a stovepipe solution for a particular center. Sharing data between applications was challenging, and sharing data between other agencies or allies was even more challenging. This approach to designing our ecosystem has also allowed us to share space data with allies, enhancing space domain awareness amongst the Five Eyes Alliance. The Five Eyes Alliance, composed of the United States, Canada, United Kingdom, Australia, and New Zealand, cooperates on various aspects of space intelligence, with the goal of sharing space information for use against common adversaries. We've employed the cloud-native platform, leveraging industry best practices to provide a resilient operational backbone in order to host coalition-focused space command and control capabilities. Today, we share information and applications that our allies in the UK, Canada, and Australia can see in their own country's space operations center. As our efforts continue to advance and further mission capability, our collaboration with industry and our partner nations will continue to grow, enabling a more robust and resilient ownership of the space domain. Today's quickly changing threat environment requires the delivery of more agile, integrated, and resilient effects in, from, and to space to meet the national security objectives and to ensure the future and safety of every American. It is exciting to see how software is revolutionizing how we solve problems and can adapt quickly to anything thrown at us. Thank you for your time and have an amazing Space Force Day.
Thank you, Colonel Krolikowski. That's an excellent story to finish on. I can only imagine how hard it must be to crunch all that data in a timely fashion and manage the complexities involved in sharing that data amongst several nation states.
I know, it's impressive, right? But that's it for today here on the main stage at SpringOne. We start again tomorrow. Let me try and get these times right. We've got 6 a.m. Pacific, 9 a.m. Eastern, and about 3 p.m. Central European, if you're in Europe, where we'll have some more legends of software talking at SpringOne, including Craig McCluskey, co-founder of Kubernetes. So be sure to set your alarm. All that's left for this section is to remind folks how they can interact with us here at SpringOne. So first of all, don't forget to sign up for the Slack. There's been over 1,000 people signed up for the Slack at least, I think. So that could just be just for the main stage. So always go and log into Slack, join all your sessions on Slack. Secondly, Twitter, get in touch with us using @SpringOne. And also the hashtag SpringOne.
We also have a great diversity and inclusion session tomorrow, applying a racial equity lens to working with data and digital access. It starts at 11:30 a.m. Eastern, so sign up now. And finally, let's once more say a huge thank you to our sponsors who make this all possible and free. So we have, Accenture and Okta, so many companies here that are using Spring and wanting to get back to the community. We really do thank you. So Ben, are we about done?
Yeah, so that's it from Brian and I for today. Enjoy the rest of your day wherever you are, and we'll see you back here tomorrow for some more SpringOne 2020. Goodbye.